Hi everyone, in this video I'm going to show you how to interpret and solve sequential move games. So in a sequential move game, a player will make a choice. This choice is then observed by the other player who then chooses an action accordingly. Okay, so let's consider an example of market entry with a market entrant labeled E and an incumbent already in the market. So in this game, the market entrant can either choose to enter or not enter. The incumbent then observes this decision and decides to punish the entering firm or to accommodate them. And in each brackets, the first number represents a payoff going to the entrant firm, and the second number represents a payoff going to the incumbent firm. So the way we go about solving sequential games such as this one is through a method called backwards induction, which I will now demonstrate. So at this point in time, we consider that the incumbent will either choose to punish or accommodate, and they want to do whichever one will give them a bigger payoff. So they're comparing 5 with 10, and they would obviously prefer 10 to 5, so we'll mark that. So now, the entrant firm knows that if they enter, the incumbent firm will always choose to accommodate. So at this point, they are comparing a payoff of 0 and 10, and obviously they prefer 10 to 0. So we find that the Nash equilibrium and predicted outcome of this game is enter, accommodate for a payoff of 10 to both firms. Okay, let's consider another game with players 1 and players 2 who each have some arbitrary action to choose, K and Z. So again, we'll solve this game by backwards induction by first considering which action player 2 would go for in any given situation. So we can see if P1 goes for K, player 2 either has to choose K or Z, either for a payoff of 10 or 20, and of course they would prefer 20, so we'll mark that. And then again, now player 2 either has to choose between 10 or 15 in this situation, and of course they would prefer 15. So now, knowing which way player 2 will go under either situation, player 1 must now make their choice of K or Z by choosing from either 10 or 5, and of course they would prefer 10. So we can say that this will be the outcome of the game. Player 1 chooses K, player 2 chooses Z. And in this game, we can also say that there's actually a second mover advantage because the second mover in this game gets their desired outcome with the highest payoff, while the first mover is unable to achieve the greatest payoff that they would ideally want. So that's it for this video. I hope you found it helpful, and please feel free to leave any feedback or questions in the comments. Bye.